Question 4, the table shows the edge length and volume of several different cubes. And this edge length here, I'm going to put is in feet. Complete the table using exact values. So, remember, a cube has 3 dimensions. It has length, it has width, and it has depth. Or height, I guess we'll say. Length, width, and height. So if I want to find the volume of a cube, and remember, if it's a cube, all of these are going to be the same. So the width, the length, and the height in a cube are all the same. So if the edge length is 3, if this is 3, then that means this is 3 and this is 3. So if we want to find the volume, we would take all 3 of these and multiply them together, because remember that volume is just length times width times height. Or if you're talking about a cube, it would just be side cubed or edge cubed. So 3 cubed would be 27 feet cubed. We have that each side is, the volume is 64. So what that tells us is that all 3 of these are the same length because it's a cube. And so we take x times x times x to get 64. So what that tells us is that x cubed, there's some number that we multiply times itself 3 times that we get 64. So you could either think about, if I wanted to find what one of these is, I would take 1/3 to the power of 1/3. And so 3 times 1/3 would just be 1, which is x. And then I would just find the number that multiplies itself 3 times to get 64, which would be 4. Or you can think of this as x cubed is equal to 64. And so instead of taking the square root, which would be without an index here, we take the cube root. So when these two match up, then I know the radical and the exponent will cancel each other out, and we still get x is equal to 4. So the edge length in this one would be equal to 4. For the next one, again, we have the actual volume, and what we're trying to do is we're trying to find the edge length. And so if we set this up the same way we set up the last one, we would have x times x times x is equal to 85. So x cubed is equal to 85. So there's some number that when we multiply it times itself three times, we get 85. So we can take the cube root of both sides. Remember, your index and your exponent have to match, and whatever you do to one side, you have to do to the other. So the exponent and the radical would cancel out. And because this says using exact values, this is actually the exact value right here. If we were to calculate this in the computer, find the cube root in the computer and round it to a decimal, that's an approximation. So this is actually the exact number. So this is the cube root of 85. So notice here, the cube root of 85 gives us a volume of 85. So let's look at the next one. All right, so on the next one, we have the cube root of 100 is equal to each one of these sides here, and we need to figure out what the volume is. So if we take each one of these sides out and we replace it with the cube root of 100, then when we multiply these 3 together, that should give us our volume. So we're taking the cube root of 100 to the 3rd power. So just like before, when we had 100 cubed and we had the cube root out here, those canceled out. It works the same way this way. So you have the cube root and the cube cancel each other out, and so we get 100. So just like this one, if you have a cube root of 85 and you cube that, you get 85. If you take 100 cubed, or the cube root of 100 and you cube it, you get 100. So once again, they give us the volume, and we have to come up with the side length. So again, we're looking for the value of x on each of these three sides. So x cubed is equal to 125. We're going to take the cube root on both sides. Remember, your index has to match your exponent. So x would be equal to 5. For the last one, this one is similar to two previous ones. If we have the cube root of 147 and we're trying to figure out what the volume is, we have the cube root of 100 cubed is 100. The cube root of 85 cubed is 85. So if we take the cube root of 147 and cube it, we should get 147 as the volume.